Welcome again to this session. We are going to learn water and hydrogen as a topic. So water and hydrogen is in Form 1, the last topic in Form 1. So what are the examinable areas? What is set? What should you know when you talk about water and hydrogen? So number one, we are looking at this topic tries to explain the chemical sources of water. So the chemical source of water is hydrocarbon. So hydrocarbons, you must know the definition of hydrocarbon. So hydrocarbons are compounds of carbon and hydrogen. So hydrocarbon is a compound of carbon and hydrogen. So there's a definition that is mostly set. So hydrocarbon refers to a compound of carbon and hydrogen. So all hydrocarbon burn to form water and carbon dioxide gas. So any hydrocarbon will burn to form water and carbon dioxide gas. So if you are asked what are the products of hydrocarbon, so water and carbon dioxide gas, water and carbon dioxide gas. Now, so we have said any hydrocarbon will burn to form water and carbon dioxide gas. So what are the examples of hydrocarbon? So the examples of hydrocarbon include candle, petrol, diesel, kerosene, petroleum gas. So all these ones are examples of hydrocarbon. Now, so there's an experiment for burning a candle in air. So what happens when a candle is burnt in air? Now, we set up an experiment is set up as shown below, as shown in this diagram. So we have a candle burning, and then you have inverted funnel. So this inverted funnel, this funnel is inverted. Then we have a test tube. We have test tube A and we have test tube B. So test tube A contains is immersed in ice cold water. Test tube B contains calcium hydroxide. So, and then we have this to suction pump. So this diagram must be understood well so that you can be able to answer the questions that follow the diagram. So what is asked in this diagram? Now, questions asked in this diagram. Number one, you may be asked to name the products formed when a candle burns. So product formed when a candle burns, as we have said before, is water and carbon dioxide. And then number two, you may be asked the role of suction pump. What is the role of suction pump? So the suction pump pulls or suck the products of the burning candle into the inverted funnel. So it just sucks or pulls the product. And then you ask, what is the role of inverted funnel? So the role of inverted funnel is to channel the products of the burning candle into the delivery tube, just to channel the product. So inverted funnel is just to channel the product into the tubes. So then you are asked again to state and explain the observations made in test tube A. Because test tube A is inserted in a cold water, and you have said the products of the burning candle is water and carbon dioxide gas. So in test tube A, you will observe a colorless liquid. You don't say it is water because already you don't know whether it is water. But what is observed is a colorless liquid. So test tube A, you will observe a colorless liquid. colorless liquid. So in test tube A, we say test tube A observation is a colorless liquid. Then explanation. So water vapor condenses to form water. So you can see in test tube A we have ice cold water. So the ice cold water will condense the water vapor to form water, and water is a colorless liquid. So we'll observe a colorless liquid. Then test tube B. Test tube B, we have said it contains calcium hydroxide. So in test tube B, as we have said, it contains calcium hydroxide, and calcium hydroxide is used to test or to absorb carbon dioxide. So then carbon dioxide gas reacts with calcium hydroxide to form calcium carbonate. So now what we'll see in test tube B is a white precipitate. Then explanation, carbon dioxide gas reacts with calcium hydroxide to form calcium carbonate, which is a white precipitate. And then now, what happens when the suction pump is closed? So when you close the suction pump, the candle goes off. Remember, we say the suction pump is the one that sucks or pulls the product. The candle burns to form carbon dioxide gas and this water, and then the suction pump pulls the product. So if you close it, the products remain, and the product that remain are carbon dioxide gas and water. And so carbon dioxide gas doesn't support combustion, so there will be build-up of carbon dioxide gas. There will be build-up of carbon dioxide gas, and the candle will go off. There's a build-up of carbon dioxide gas in this place, and the candle goes off. So basically, these are the questions that are set in that's this at the introduction part of water and hydrogen. These are the information you need to know. These are the objective of the diagram and of the introduction in water and hydrogen. So continue subscribing. You can reach us on 0728 700 429. So thank you. See you in the next episode.